Thank you, and this is Introduction to Declarative MDM. Before we get started, there's two things I'd like to mention. The first is that all the slides, speakers notes, and the demos are available for download, and I'll be providing a link at the end of the talk. Sadly, the previous Bananas and Pajamas entertainment will not be included with that for copyright reasons. I tend to be one of those folks who can't keep up with the speaker and take notes at the same time, so for those folks in the same situation, there is no need to take notes. Everything I'm covering is going to be available for download. So I'm also going to be using the following acronyms frequently during this talk: DDM and MDM. Here is what they stand for. If you don't understand what they mean now, hopefully you will by the end of the talk. So let's start by getting on the same page. What is MDM? Well, in the context of Apple devices, Mobile Device Management, or MDM, is a delivery mechanism for distributing data and settings to Apple devices. Now, this includes iPhones, Macs, iPads, Apple TVs, and as of this year, Apple Watch is now being added. So more specifically, MDM is an API for sending device management commands. Now, not all these commands are backwards compatible, so MDMs for a specific OS version and later won't work on earlier OS versions. So when did MDM enter the picture? Well, Apple first rolled it out starting with iOS 4, and it came to the Mac platform starting with macOS 10 Lion. tvOS is an outgrowth of iOS 9, so the ability to use MDM has been there on tvOS from the start. So you can use MDM to push email, security settings, applications, app settings, certificates, and even media content to Apple devices. So there are two major components to MDM. There is Apple's push notification service, and then there's the MDM server used to manage those devices. So let's take a look at APNS first. So when you take your new Apple device out of the box and power it on for the first time, it doesn't yet know how to talk to APNS. That's because it may have been sitting in that box for a while, and Apple wants to make sure that it is getting the latest information. So what the Apple device does know is the address of the initialization server that it's supposed to talk to, and that it is supposed to download what is called a bag file. Now, the bag file is a plist which contains the necessary data for the Apple device to start talking to APNS. Clicker not working, so there we go. So now that the Apple device knows how and where to start talking to APNS, it opens a connection and it says hello. APNS says hello back and provides a certificate. The device checks the certificate and verifies that it's valid, telling the device that APNS can be trusted to communicate with. The device has an Apple-issued device certificate, so once the device is verified that the certificate provided by APNS is valid, it sends that device certificate up to APNS. APNS checks the certificate that it's been sent by the device and verifies that it's valid, telling APNS that the device can be trusted to communicate with. Now, once both sides know that the opposite end can be trusted to communicate with, they will exchange cryptographic ciphers and start a secure conversation. Now, APNS is going to be used by Apple devices regardless of whether they're enrolled in a mobile device management service or not. For the various apps on your Apple device that use push notifications, APNS is how those push notifications are getting sent to that device. Now, APNS also requires having certain ports open outbound. I repeat, outbound. Details are available via the link on the screen. Now, this is the part of the KBase article where your InfoSec and firewall folks may start shaking their heads and saying things like, no, can't do this. Now, for those folks having that argument with their security or network folks, here are some important facts to know. Now, in the event that your network or security folks absolutely won't do it, new development, Apple does provide a more restricted set of IPv4 and IPv6 ranges to use. This is relatively new, and it is most welcome. So once the argument is over and they've agreed to open up the necessary ports, you may find that they didn't actually open up the ports. So to check this, 2Canoe software makes a great diagnostic tool. Now, for more information about APNS and how it works, I encourage you to check out Brad Chapman's talk on the subject. It was given at the Jamf Nation User Conference in 2017 and is available via the link on the screen. So now let's turn our attention to the other half of mobile device management, which is the MDM server. So ultimately, what's an MDM server? Well, when you get down to it, it's an HTTP server that responds to communication either with a plist containing a command or HTTP 200, which is the OK command. Response. Most traffic between a device and the MDM server it's enrolled with are going to be plists being sent back and forth. Depending on the contents of that plist, some of what's being passed will be digitally signed or encrypted. For example, this is what a request from an MDM server for a device inventory may look like. This is what a command from the MDM to install a certain management profile may look like. Now, an MDM server also needs certificates. There are two types of certificates specifically used by MDM servers. There is the APNS vendor certificate and the APNS push certificate. So the first is the APNS vendor certificate. So this is a special certificate used to generate the certificate signing request for an APNS push certificate prior to uploading the request to Apple for an APNS certificate. Now, for those folks familiar with Jamf Pro, you may have seen this as part of setting up or renewing your APNS push certificate. So as part of the APNS setup or renewal, you can select the option of downloading a signed CSR from Jamf Nation. So once you've provided the necessary credentials, a signed certificate request for APNS is then downloaded to your Mac. What's happening in the background is that your Jamf Pro server is communicating with a backend system with access to the APNS vendor certificate to generate that certificate request for your Jamf Pro server. So what's generated is an encrypted plist that is ready for uploading to Apple's push certificates portal. So that brings us to the APNS push certificate. So this is a special certificate used by MDM servers to communicate with APNS. So if you've ever set up or renewed an APNS push certificate, you have used the site up on the screen. This is where you take the certificate request that's generated by your MDM and use it to get a push notification certificate. So your ability to generate a push notification certificate is tied to an Apple ID, which you use to log into the portal site. So when it comes to the Apple ID used for your APNS certificate, I do have some short do's and don'ts to keep in mind. Where possible, you should have one Apple ID per APNS certificate. Please make sure you have this documented. You should also make sure that you're not using a personal Apple ID or one tied to your work email address. If you can, have a dedicated email mailbox set up for just the Apple IDs involved. Also really important, do not lose the password for the Apple ID in question. Now, with managed Apple IDs, you can have an APNS certificate associated with a managed Apple ID. This helps with a lot of this because it's going to be in Apple Business Manager or Apple School Manager, and you can reset the password and also the, trying to remember, it's a two-step verification where it uses the SMS messages. It's not technically two-factor, two-step authentication. So that does help out a lot with this. So that said, if you are using a personal Apple ID and you do lose the password to the Apple ID in question, Apple does have a process to transfer APNS certificates to another Apple ID. I have a blog post on how to do this, available via the link on the screen. So to show what can happen if you don't follow those rules, here's what the portal looks like when I log in using my personal Apple ID. I've got two active APNS certificates, and now I have to figure out which specific APNS certificate goes with my MDM server. This is important for reasons I'll discuss in a bit. So I think I got the right one figured out, so let's upload that CSR. Great. I've got a new APNS push certificate. Let's download it and get it over to my MDM server. This looks bad. What happened? Well, Apple's push notification service is a chain of trust, and it has multiple security factors built into that chain. The first part is the certificate that I received from the push certificate portal. Now, when inspected, the certificate looks like this. The second part is what's known as the topic, which is a specific UUID identifier associated with your MDM server. Now, the certificate generated by the push notification portal will include the topic in both the common name and the user ID fields of the certificate. Now, this information is also visible if you click the Info button next to the relevant certificate on the portal page, which I did not do. So the topic is also embedded in the MDM profile that your MDM server issues to your Apple device, with the topic field listing the user ID field of the APNS push certificate. So to circle back to my earlier problem with the push notification certificate, I had accidentally created a new push certificate for my MDM instead of renewing my existing one. Because that topic is a UUID, it will be unique per MDM push certificate, and it can only be included in push notification certificates if that certificate is being renewed. Oops. Now, fortunately, my MDM had warned me before I actually uploaded the new certificate with a different topic. Now, if I had gone ahead and uploaded it, I would have broken the middle of my trusted chain of certificates. All devices enrolled with my MDM would have instantly lost the ability to communicate with the server because APNS would no longer be able to point them to the correct MDM server. That is a resume updating experience, career limiting experience. It's not good. So once I went back, created a new CSR, and made sure to renew the correct APNS certificate this time, everything was fine. So with that knowledge, let's take a look at how the MDM server talks to APNS. So like an Apple device, it opens a connection, and it says hello. APNS says hello back and responds with the certificate. The MDM server checks the certificate and verifies that it's valid, telling the server that APNS can be trusted to communicate with. The MDM server now sends back the APNS push certificate it was issued by the Apple push certificate portal. APNS checks the push notification certificate it's been sent and verifies that it's valid, and this tells APNS that the MDM server can be trusted to communicate with. Now, once both sides know that the opposite end can be trusted, they exchange cryptographic ciphers and they begin a secure conversation. However, the push certificate and the topic are not the end of the chain of certificates. The last link for devices is what's known as the device token. So this token is generated by APNS and is unique to the device. So these tokens are the same kind of tokens that APNS will assign to applications that use push notifications. So in this case, the application in question is going to be your MDM server. But how does the device get the token from APNS and know to forward it to the MDM server? Well, this happens as part of MDM enrollment. The device connects to the MDM server and sends in an enrollment request. Now, as part of the enrollment process, the MDM configuration profile is downloaded to the device. The device is now managed by the MDM server, and it's able to communicate securely. Now that the MDM profile is in place on the device registers itself with APNS using that topic. APNS then generates a token based on the combination of the device ID and the MDM topic. Once APNS has generated the token, it sends it down to the device. Now, once the token is sent to the device by APNS, the device then forwards it on to the MDM server. Once the MDM server has it, the token is associated with the MDM's record for that device. Now, this device token may change occasionally. When a change is detected, the device will automatically check in with the MDM server and report what its new token is. So along with the token generated by APNS, the device itself also generates a unique string known as push magic. So this is sent to the MDM server, and it's associated with the MDM's record for that device. So this push magic value is a UUID, which ensures that the MDM server is talking to the right device when it sends commands. So now everything involved has the right cryptographic trust relationships in place to communicate securely with each other. So let's use this to send commands to our managed devices. So first step is the MDM server creating a notification payload using the token and push magic of the device it wants to send something to. Next, APNS forwards that notification to the device. So the device verifies that the topic, token, and push magic match, then accepts that notification. The device sends feedback via APNS that it successfully received and decoded the notification. Now, in response to the notification, the device checks in with the MDM and gets whatever command or configuration settings that the MDM server has for it. Now, one thing that's important to understand is no management data ever goes over APNS. APNS is only ever used as a trigger mechanism to make the device ask its MDM for commands to run. So this genericness is what allows APNS to be used by absolutely everybody who needs to send push notifications, because APNS is only ever telling the device to check in with whatever originally generated that notification for it. So APNS is also pretty secure because of its verification scheme. By the time an APNS notification reaches its target device, it relies on the push notification certificate being valid, the topic being valid, the token being valid, and the push magic string being valid. If any of these things is not valid, that notification is automatically discarded by the device. So that's MDM, which we've all been using for over a decade to manage Apple devices. So what's declarative device management, or DDM? Here's what it is. It is a new data management paradigm which uses a declarative data model which is designed to address and avoid performance and scaling issues that are commonly seen with MDM. Here's what it is not. It is not a new protocol. DDM has been added to the MDM management protocol to make switching to DDM easier. So why do we want to use this thing? Well, to make a long story very short, MDM without DDM is a very server-focused management protocol. The endpoints are told to check in with their MDM server. The endpoints do, and the server tells them to do something. Over and over, endpoint checks in. Server tells the endpoint to do something. The endpoint does it. The server in this scenario is doing pretty much all the work of figuring out what to do. The endpoint's role is doing what the server tells it to do. Now, Apple wants to ensure that the MDM protocol remains responsive and scales to meet a growing population of devices, so changes are needed. So DDM is designed to take some of that load off the server by moving some of the management to the endpoints. With DDM, the endpoint is being given more responsibility for managing itself and deciding when to report information back to its management server. So this change does three things right away. One, it reduces the network resources needed for MDM communication because now there's less of it. Two, it's reducing load on the management server because, again, there's simply less communication for it to process. And three, it is saving time overall because now the endpoint is doing things locally on device and there's no going back and forth. So like MDM, DDM uses a structured data model. So let's take a look at what this looks like, starting with declarations. So declarations are the policies sent to a device, and they have a structure that looks like this. And surprise, it's JSON now instead of XML. So type identifies the policy that the declaration is using. Identifier provides a unique identifier for the declaration in the form of a UUID. Server token provides a unique identifier for the current version of the declaration based on the identifier value in the declaration. This will also be in the form of a UUID. And payload contains the settings for the policy being sent by that declaration. So as a quick review, here's all that makes up the structure of a declaration. And just as a reminder, no need to take notes. All this is going to be available for download afterwards. So let's dig into the various declaration types. The first is the configuration type, and it should be pretty familiar. It's a policy definition, similar to what's used in MDM profiles. So next, there are assets. And these are data needed by a configuration, like MDM URLs, certificates, email addresses, contact information, whatever. So here's how an asset looks as a declaration. Now, the great thing about assets in DDM is that they can have a one-to-many relationship. One asset can be used in multiple configurations. So why is this awesome? Well, this is a great advantage for DDM configurations over MDM profiles, as MDM currently requires that resources for that profile need to be available inside that profile. For example, if you need to have the same certificates for authentication for both Wi-Fi and VPN, this either means that you need to have your Wi-Fi and VPN configuration in the same profile as your certificates, or you're duplicating the same certificates in the profiles used to configure Wi-Fi and VPN on your devices. So in addition, anytime we would need to update a certificate in this scenario, it is necessary to remove and reinstall that profile. For folks with Wi-Fi, I'm sure I don't have to tell you about this, because especially in the case of a Wi-Fi profile update, this may mean that removing the profile means removing the Mac's only way of communicating back to that MDM server. So a removal of the profile may be the only step that that device accomplishes, because now it can't communicate with the MDM to put the Wi-Fi profile back. So with this one-to-many relationship, you can change one asset, and it'll update in all the configurations which reference it. So this is a huge step forward in functionality, because now we can make incremental updates to a configuration without having to re-push the profile. So going back to the Wi-Fi profile issue I just mentioned, this should mean that the Wi-Fi stays up and working the whole time during the profile update process. Activations are a group of configurations that get applied to a device. Now, they also specify the logic that determines how and when the policies defined by configurations get applied to the managed device. So these configurations are also applied atomically to the device, such as that the system applies all reference configurations together, or it applies none of them. So all the configurations and assets referenced by those configurations, so not just the configuration, but everything referenced by it, they need to be valid in order for the system to apply that activation. So if you have an invalid configuration or an invalid asset defined in a configuration, nothing happens. None of your configurations get applied. So if you have something that's wrong in one of those configurations, boom, none of them will apply. So activations in DDM can have a many-to-many relationship, where configurations can be referenced by multiple activations. So one activation can hit multiple configurations at once, and a configuration can be used by multiple activations. So this means that you can be having your devices process complex business logic, while DDM means that the devices are handling this logic autonomously in place of the server having to do all that work, which means less load on your server, which means it can stay more responsive for other work. So along with activations, we get predicates. So these determine the activation state, if active or not, on a device. So this is going to use Boolean logic, and an activation will be processed by a device if the predicate is evaluated to be true. So here's an example of our previous activation declaration, where the predicate is set to only evaluate to true on iPads. Now, the final kind of declaration is a management declaration. Management declarations are used to send overall management state to the device. So this includes a declaration describing details about the organization, as well as a declaration that describes the capabilities of the MDM server. So these declarations are helpful for conveying static data to the device that shouldn't change. So those are our 4 types of declarations, but there's even more to dig into. So next, let's look at DDM's status channel. So in the DDM communication model, there's communication between the management server and the device going on. But there is less communication because of status channel. Status channel is a way for the server to subscribe to only that information that your server needs. So once the server has subscribed to the specific status items that it is interested in, the client will report to the server only on those status items. Once again, reducing communication, reducing load. So this model of endpoint to server communication cuts way back on the unneeded chatter which happens with MDM, and it provides the server only that information that it is actually needing. Now, status items are identified by key paths, which consist of period-separated string tokens, and examples of these are shown on the screen. So here's how a status channel subscription may look like. And a response from the endpoint may look like this. Now, Apple's products have a long life cycle, so it's essential to maintain compatibility between different versions of an MDM solution with Apple's devices of various ages and capabilities. So declarative management means that both the device and the MDM server are now going to advertise supported capabilities to each other. So each side of the management system is now aware of what the other side supports, because each side is advertising its supported capabilities to each other. So each side knows when it can start taking advantage of new features. Now, these advertisements include a list of supported features representing both major and minor protocol updates. So the endpoint will advertise supported payloads, including that full set of declarations and status items supported by that device. Meanwhile, the MDM server will advertise its capabilities to the endpoint via a management declaration. So when the MDM server is upgraded, it will synchronize all new capabilities with the device like it would any other declaration. And that allows the device to start working with the MDM server's new features. Likewise, the endpoint sends new capabilities to the MDM server as a specific status item when that device's capabilities change. New operating system means new capabilities. Let the MDM server know. Upgraded your MDM server, it's got new stuff, let the endpoint know. So DDM is integrated into the MDM protocol, as I mentioned before, and it uses it for managing the enrollment and unenrollment process, for handling the HTTP transport communication, and for device and user authentication. This is one of the reasons why we went through all the MDM stuff as well. DDM is just riding along. So DDM should not interfere with existing MDM behavior, except where Apple says it does. And more on that in a bit. So declarations, in fact, leverage existing MDM behaviors using an MDM command for activation and an MDM check-in request for synchronization and status reports. This is intended to ease the migration process from MDM to DDM. In fact, you can send an existing MDM profile as a configuration. So this allows profiles to be used with DDM, which in turn means that you can shift profile-based logic to an endpoint without having to rework any of your profiles. And just to show you that it is in fact turtles all the way down, this means that in some cases, you could have added a setting as a managed preference to Workgroup Manager in macOS 10.3 Panther server in 2003. Later, move that managed preference setting into a profile in macOS 10 Lion using profile support for MCX settings. Now, 20 years after first adding that setting to Workgroup Manager, you can use DDM to deploy that profile with that MCX setting. Now, that's some backwards compatibility. OK, so we've looked at MDM and DDM. Why do we care? What is in this for us as admins? I admit some previous talks may have stolen a bit of my thunder here, but let's just keep rolling. So first of all, let's look at some of what is available in macOS Sonoma and iOS 17. Software updates, as covered in great detail by my colleague Tom Bridge, they are manageable via DDM and can enforce deploying a specified OS version and build which must be installed by a specified time. Now, to help ease migration, DDM software update commands can coexist with MDM software update commands. Now, that said, the DDM management is going to take precedence, in this case, over the MDM commands. So this is one of those situations where DDM should not interfere with existing MDM behavior, except where Apple says it does. I mean, I don't know about you, but this is what I look like when I found out about DDM software updates. I mean, forget the rest of it. This is huge. I'm really looking forward to seeing how this works on Sonoma. Hopefully, we'll be able to all find out very soon. And I frankly expect a lot of you are as well. So DDM can also help with app deployments, with options for apps being sent to device before a specified time and only made available once that app is needed. So DDM also enables the option for the app being shown without actually being installed, giving the user the choice of when to install it. Now, one benefit of this is since the user is choosing to install, for folks that are dealing with unsupervised devices, you don't get any extra consent dialog that appears to ask someone, do you want to install this? Because they're tapping on it. They want to install it. Now, on macOS, DDM configurations can be used to specify sets of tamper-resistant systems configuration files for different system services. Our colleagues from Apple referenced that briefly during their talk earlier. And in their session at WWDC, Apple mentioned that the built-in services listed on the screen could be managed this way. Now, DDM also provides improved file vault status monitoring with a status item that will return true or false Boolean values. Now, do you, as a Mac admin, need to know all this stuff about DDM? Largely no. This is stuff your MDM vendor needs to know and figure out. However, understanding what is going on with both MDM and DDM means that we know what to ask our vendors for in terms of new features, and that's very valuable information on its own. So I see DDM as providing us as Mac admins with a deeper and wider toolkit for management than we've had before, and this is a very good thing. Now, one thing it is not, as of yet, is configuration management akin to that provided by solutions like Puppet, Ansible, Salt, Chef. With those solutions, the configuration management server provides a plan to the managed endpoint, and the endpoint makes sure that that configuration is applied no matter what. This includes automatically reverting changes to managed settings made by the end user on the endpoint. As of now, DDM's ability to report changes via status channel means that automatic reporting of changes is in there, but automatic remediation that would be handled by the endpoint, it's not there yet. I really hope this is coming to DDM. We are not there yet. So, because you can never have too much information about something that is new, I've got some useful links, some more useful links, and hopefully the most useful link you see in this entire presentation. This is how you get it all, minus, of course, the bananas and pajamas cartoon I was showing before for copyright reasons. PDF with the slides and speakers notes is available via the top link, and Keynote slides with all the slides, speakers notes, demos, absolutely everything else is available via the link on the bottom of the screen. And how are we doing on time? Oh, we got plenty of time for Q&A.
Thank you, sir.
Great talk. Thank you for all of the awesome information that's collated here and explained in a very clear way. As we look at the declarative frameworks, we get the ability to activate based on individual policies. And I think that there are some really strong use cases to be made for activate only if file vault is set, activate only if the firewall is on. What are some other things in your mind that you're interested in managing only on the activation of another part of the operating system?
Ooh, that's a good question. What I would love to be able to manage, in particular, in my shop we support only the shipping OS. For us, this is a big thing because, of course, Apple is only providing security patches. Right now, as part of ADE, automated device enrollment, you will be able to, this is a capability we've been promised, that you'll be able to set a minimum OS version for enrolling. So if someone tries to enroll a Monterey device in my ADE, one of the first things it'll do is say, oh, you're not on Sonoma, so we got to get you updated. I would love to also see that come to all MDM enrollment methods, not just ADE. And the reason I say that is because I work for a small German boutique software company that has an unreasonably large number of offices, and a lot of those offices are resident in places that ADE doesn't exist. A good example is if you look at the entire continent of Africa, there is exactly one country that has ADE, and that is South Africa. It's great that it's in South Africa, but that's a whole lot of places that don't have ADE. So, and I have offices there. So I would love to have that capability come to any kind of enrollment, which, for Jamf Pro, which is what we're using, would be a user-initiated enrollment. So that's one capability I would love to see.
Anyone else?
Over there. So it was great to hear that all the APNS communication is authenticated and you need the token, etc. And so everything there is quite secure. I found a situation where we saw that because of something that happened on the OS, the communication between the device and the MDM server stopped, and the devices didn't check in anymore. And we didn't have any MDM communication going forward. But the DDM status channel was still alive.
Oh, that's interesting.
So we could see devices update to an iOS version that was released at a later date than the point in time where, because of whatever bug that was, the communication stopped. So I'm thinking about, is the DDM status channel in some way authenticated? Or because this hints to the DDM status channel not being authenticated, which could open a can of worms with that protocol and how that is being set up. Do you know anything about if that is authenticated or
Well, the thing
security about that part?
So the thing to keep in mind is that DDM is wrapped up inside of MDM. It's not its own separate protocol, so it is using MDM to communicate back with the MDM server. So all the security that applies to MDM communication would also apply to that DDM communication. Now, I don't understand why MDM stopped and DDM kept going, but in terms of the security, the same stuff should apply.
Okay, so it should, but yeah. Interesting how that issue evolved in that case.
Yes.
Yeah.
But in terms of like the going back and forth between APNS and the MDM server, to the best of my knowledge, none of that changes with DDM as opposed to MDM.
Okay. Another question, which might be quite easier. You mentioned push diagnostics from Two Canoes, which is a great software.
Yes.
How would you rate it compared to the Mac evaluation utility, or why are you using Two Canoes push diagnostics instead of Mac utility?
To be honest, it's because it's the axe I know and I trust. You may find that you trust the other stuff better, but I've yet to have the push diagnostics tool let me down. Now, admittedly, I have only used it in the shops I've worked at, but that is why I reference it, and that's why I'm linking to it. Speaking of which, I'll put that back up on the screen for those who wanted to see that.
Question over here as well.
Hi, Rich. Over here?
Sorry, where am I looking?
To your left. It's me.
Okay.
The original MDM, obviously you could check on the local computer in library managed preferences for the MCX that was being applied to the machine from MDM. Now I understand DDM is more of a black box on the machine. It's in a protected area. Are there any good ways of seeing what DDM is being applied to a computer from the local computer?
At the present, you're mostly going to be seeing that on the MDM servers side. I did catch a mention at WWDC that eventually the ability of profiles to write information to library managed preferences is going away. I don't know the time frame. I don't know, what exactly that means, if something's going to replace it, but I have heard that eventually it is going to go away.
Do you see stuff in the local logs as it's applied?
Well, here's where we're getting into our vendors need to make these changes before we're going to be able to see them on our end. So as vendors deploy DDM more and more, like for example, right now, a lot of MDM vendors are using this right now for inventory update information being sent back to the MDM server. That's not exposed to us, aside from, of course, we see it in our MDM server console. But there's nothing really on the endpoint that we can look at to say, well, when did DDM do this? So for right now, our visibility into what DDM is doing on the endpoint is very limited, and it's going to come through your MDM server.
Cool. Well, welcome.
I'm just curious about the adoption rate on Sonoma in your shop now, 1 week later. Do you have a?
Hold, please. Let's see now.
A small boutique shop.
It is run by lovely people in Germany. Where is my mouse? There we go. Enter full screen. So that big pinkish thing, that's Sonoma.
Okay. Thank you, Rich. Thank you very much.